So for number 12, we're going to use the diagram to determine the measure of each of the following angles. Okay, now remember, all of these angles are considered central angles. Okay, so, and as I mentioned on the previous page, central angles, whatever the measure of the arc is, the angle is congruent or equivalent. So if the first one asks for angle AOE, so angle AOE is this angle here. Well, that intercepts arc 154. So that is the measure of that angle, 154 degrees. AOB, which I just did, that's 60, because the intercepting arc is 60. I'm going to skip the next two for a second, because I want to show you that DOE, that angle is 86 degrees. Okay. And then the last two, BOC and COD, if you'll notice, these two arcs are congruent. And I'm sure some of you are thinking, well, how can we know what the measure is, because we're not told what the arc is. But what you do know is that there is a 360 degrees total in a circle. So on your calculator, if you take 360, subtract 154, subtract 86, and subtract 60, we will know how many degrees are left in the circle. So let me do that. Okay, so on the calculator, after you subtract 154, 86, and 60 from 360, we are left with 60 degrees. Now, if both angles, BOC and COD, are congruent, clearly I want to take that total of 60 degrees and divide it equally between those two angles. So each angle would equal 30 degrees. And if you were to go back and check and add all of these up, they would total 360. Okay. So go ahead and write in the measures for arc BC, BD, BAE, and BDE. Okay, so as we just determined, BC, we said was 30. Now BD, I hope you were inquisitive enough to realize that if both angles are 60, I'm sorry, yeah, both angles are 60, both angles add to 60, 30 and 30. So arc BD would also be 60, so just add the two up. BAE, now remember, follow the order of the letters, so BAE, that encompasses the 60 degree arc of AB and the 154 degree arc of AE. So together we would add these up to get 214. And then arc BDE, so B, D, and then E. We already know what BD is. We know BD is 60. So to add on DE would just be 86 plus 60, which would give me 146. Okay. Try number 13. And you're going to want to keep in mind that JM and KN are both diameters. And don't forget that a diameter cuts the circle in half, creating two 180-degree halves. Give it a try. So if you haven't finished yet, go ahead and pause the video. But so we're looking for our KLN. So follow the letters in order, KLN. Okay, if you notice, that is half the circle. So that's going to be 180 degrees. Now, next one, angle JOK. So JOK. All right, now, here, JM is also a diameter. So that means from J to M is 180. It also means that K to N is 180. Okay, so if you notice, I have JON, this is 126. So if I take the difference, 180 minus 126, I can get the measure of JOK. So 180 minus 126 gives me 54. Okay. Now, angle MON. So MON. Okay. I want you to notice something. Now, I know it's on a circle. And maybe it might be easier if I get rid of some of this stuff here so it's easier to see. Okay. But we said that this was 54. Okay. And we're looking for MON. Now, if you notice, these types of angles we have seen before. They're drawn in a circle, but they are still vertical angles. So this is also 54 degrees. Now, you could have also looked at it saying, oh, okay, well, JM is a diameter, so 180 minus the 126 would give me the 54. So either way, those two angles are congruent. And then we're looking at arc for arc LM. Now, okay, again, we're told we have two congruent angles here. We know that KN is a diameter, and that these two angles are congruent. So if I do 180 minus 54, we will get 126, as we had earlier. And because both these two smaller angles are congruent, to divide the 126 degrees evenly between the two angles, I can divide by 2. And that will give me 63 degrees each. Okay, because again, the arc has the same measure as the angle formed from the center of the circle. Okay, what is the definition of arc length of a circle? Okay. Now we talked about arc earlier, and remember arc is a portion, excuse me, an arc is a portion of the circle or a portion of the circumference around the circle. So the arc length is going to be the actual physical length of the arc in inches or centimeters or feet, whatever unit of measure that you have. So imagine taking a string and wrapping it around the outside of a circle and then marking off, like if I wanted to find out what the length of KL is, I could take the string and mark, put a line, put a string at the beginning of K, bring it over to L, and then we would lay it out flat and measure it with a ruler. That's arc length. Okay. So using the diagram from question 13, if the length of KO is 6, so that is the radius. Okay. What is the length of the arc LM? Okay, so we want to find out, we know that the radius, so KO, that remember, and the radius for any circle will be exactly the same. So let me do this. Let me get rid of some of this so we can really take a look at it. Okay, so we know KO is 6 centimeters. Okay, so that means every radius is 6 centimeters. Okay, doesn't matter. And we want to find the length of this arc here. Now we determined that arc LM was 60 degrees, and so that is also, that's the measurement of the angle. Okay, so again, remember that the arc of a circle is a portion of the circumference. So to find the length of just this portion, we're going to need to use a fraction. I know you all hate fractions, but if you think about it, it totally makes sense. So if an arc is a portion of the circumference, we first need to find out what the circumference is, total circumference. And remember, that formula is 2 pi r. Okay, and we were told that my radius is 6. So that means 2 times pi times 6, which is 12 pi. And when I multiply 12 times pi in my calculator, I get this total circumference to be 37.7 centimeters. Okay, so that's all the way around. Okay, so that's like if I was to take a string and put it at the center of the circle, and my length of my string was only 6 centimeters to measure all the way around, I would get 37.7 centimeters. That's the total circumference. But my question is, okay, if the whole circle is 37.7 centimeters, what portion of arc LM, what's the length of just that portion? Well, LM is 63 degrees, okay? That's the, remember, fractions are parts to whole, okay? So I'm going to do 60 degrees, and my total, remember it's whole number of degrees in the circus, yeah. I feel like school lately has been a circus. The total number of degrees in my circle is 360. So that's how I can represent the portion of arc LM is 63 degrees over 360. Now, all I have to do to find out what the arc length in centimeter is for LM is take my total circumference of 37.7 and multiply it by 63 over 360. Okay, now remember, when you multiply a whole number times a fraction, put it over 1 and multiply straight across. So I'm going to do 37.7 times 63, which gives me 2375.1, and then I'm going to divide that by 360. So the portion of arc just LM out of the total 37.7 centimeters is actually 6.59, or approximately 6.6 centimeters. Now, of course, you could do this division first. You could do 63 divided by 360, which equals 0.175. And then you could just multiply that times the total circumference of 37.7. Either way, you're going to get the same answer. Okay, so it doesn't matter, whichever you prefer. So LM represents 6.6 centimeters of the total 37.7 centimeter circumference.